Today we are looking at Lesson 6-8, which is expressing and interpreting remainders. There are three different ways that we can interpret remainders, and it depends on the context of the story problem. So we are going to look at those three different ways and the situations in which we would use them. So our first story problem says 3 students share 13 sticks of gum. How many sticks of gum does each student receive? How many sticks of gum does each student get if they receive equal shares? So a key word here that we're looking at is equal. It's very important that we note this word equal. That's the whole point of remainders and division, is we're looking at equal shares. We want to see how much each person gets for an equal amount. So if we look at this story problem, we see that we're talking about 13 sticks of gum and 3 students. So we know that our story problem, or let's back up a second, our number model with our unknown is going to be 13 divided by 3 equals, and we could put a G for gum. So we have 13 sticks of gum divided by 3 students equals how many sticks of gum each student is going to get. So I'm going to rewrite this problem now in order to solve using division. So I have 13 divided by 3. If you remember to the last few lessons, I'm going to ask myself, okay, how many times does 3 go into 13 evenly without going over? So as close as I can possibly get. And I think of my fact 3 times 4, which will give me 12. So I know that 3 can go into 13 at least 4 times. And it's going to give me 12. 3 times 4 is 12. So I'm going to subtract. And 13 minus 12 is 1. So I know right now that my answer is 4, remainder 1. Now the first strategy, or the first way I should say, that we can interpret remainders that we are looking at with this story problem is to divide remainders, or divide the remainder into fractions. You're going to see this most commonly with story problems that refer to food. So if we look at this, we have 4 remainder of 1. Now I want to draw a picture so I can portray it a little better in my mind. So right now I have 3 people. And I just found by doing the math that each person gets at least 4 sticks of gum. Because I just found that 13 divided by 3 is 4, remainder 1. So everyone gets at least 4 sticks of gum. So we can see this by drawing it out. So this person gets 1, 2, 3, 4 sticks of gum. This person gets 1, 2, 3, 4 sticks of gum. And this person gets 1, 2, 3, 4 sticks of gum. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sticks of gum. But we have a total of 13 in our story problem. So I have one last stick of gum over here. Now, if you think about a piece of gum, I can take that piece of gum and I can break it up evenly into 3 pieces. So I have 1, 2, 3 pieces of gum. We can also write this, if I draw it, let's look at it this way. Let's pretend that this is our stick of gum. If I break it up into 3 pieces, I have 3 total pieces, so this top one would represent 1/3. This middle one would represent 1/3. And this bottom one would represent 1/3. So each person would actually get 4 1/3 sticks of gum. The reason why we can break up this last stick of gum into fractions is because just think of food in your head. Think of a pizza. We can give each person pieces of pizza, and then with our last piece of pizza, we can divide that or cut it up into equal shares to split amongst everyone. If we have an apple, we can slice an apple and give everyone an equal amount of apple slices. And with whatever 1 or 2 slices are left over, we can evenly cut those up to disperse them amongst everyone. So we all get, back to this keyword up here, equal shares. That's what we're trying to get to. We're trying to get it so that everyone has equal shares. So our first way is to divide the remainder into fractions. So this is the first way that we can express remainders, is to divide the remainder into fractions. And again, you're going to see this with food most commonly. If we look at our next way that we can interpret story problems, I'm going to type an entirely new story problem. So this story problem says, this story problem reads, 3 children wish to divide 16 toy cars equally. What is each child's share? So let's first start by writing our number model with our unknown. So they tell us that we have 3 children and that we need to divide 16 toy cars. So I know that my number model with my unknown is going to be 16 divided by 3 equals, I'll put a C for car. So here's my number model written with my unknown. My next step is to solve. So let's find what our answer is going to be. So I am going to rewrite this so I can solve it. So I have 16 divided by 3. Again, I'm going to ask myself, how many times can 3 go into 16? As close as I can get before going over. So I'm going to think, and I'm going to do a math problem off to my head. And not 3 times 15. I know that 3 times 5 will give me 15. So I know this is the closest I can get to 16 without going over. So I'm going to put my 5 up top. And 3 times 5 is 15. And I'm going to subtract. 16 minus 15 will give me 1. So when I do this division problem, I can see that my answer is 5, remainder 1. But I want to write this out as a picture so I can see it more clearly. So I'm going to think to myself, okay, I have 3 children. And they each have 5 cars. So 1, 2, 3, 4, 5 cars. 1, 2, 3, 4, 5 cars. And 1, 2, 3, 4, 5 cars. So I have 3 children, 1 child, 2 children, 3 children, and each child has 5 toy cars. So I know that this amount displayed right here is 15 toy cars. 5, 10, 15. But I have a total of 16 toy cars that I have to split up. So I have 1 toy car left over here, which brings us to our second way that we can express or interpret remainders. And this way, we will call this, here we ignore the remainder. So this is going to be our second method. We ignore the remainder. So in this case, when we want to make sure that each child gets 16, we want to split up 16 cars equally, this last car, we can't break it up. If you think about a plastic toy car, there's no way to evenly split that car up or divide it up amongst 3 children so that they each get a portion. It's not possible. We can't divide it up. So in this case, we just ignore the remainder. So I'm just going to beep, ignore it. So each child gets 5 toy cars. Maybe the last one you can give to a sibling to play with. So that's our second way that we can interpret or express remainders. Now let's look at one other strategy. So again, I'm going to erase all this and put a new story problem up for us to look at. And this story problem says, Esteban has 29 photographs. He can fit 6 on each page of his photo album. How many pages must he use to hold all 29 photos? So Esteban has 29 photographs and he can fit 6 onto a page. How many pages must he use to hold all 29 photos? So again, my first step is just going to simply be to write my number model with an unknown. So I have 29 divided by 6. Those are my 2 numbers. And my unknown, I will put a P for photos. So here's my number model with my unknown, and I am going to rewrite it so that I can solve. So 29 divided by 6. again, I need to think to myself, how many times can 6 go into 29 without going over? So if we look, excuse me, if we look, I can do off to the side 6 times 4 will give me 24. And I'm looking to see, I need to fit 6 into 29. So if I do 6 times 5, I know that's going to give me 30, and that's too much. So I'm going to stick with 6 times 4, which will give me 24. So I'm going to put my 4 up top. And I have 6 times 4 equals 24. I subtract 29 minus 24, and I get 5. And I know that 6 cannot go into 5, so I have to stop right here, and my answer is 4 remainder 5. So just like the last two problems, I want to draw a picture so that I can visualize this a little better. So I'm going to draw the, I guess the pages of my photo album. So I have one page. I know right here that I can use at least a total of 4 pages. So I have 1, 2, 3, and 4 photo album pages. And I can fit 1, 2, 3, 4, 5, 6 pictures on each page. 4, 5, 6. 1, 2, 3, 4, 5, 6. And 1, 2, 3, 4, 5, 6. So here I have 6, 12, 18, 24 pictures. Now I want everyone to picture right now, holding a photo album. So if anybody's ever looked in a photo album before, maybe mom or dad or grandma or grandpa, or someone has a photo album in their house with a bunch of pictures in it. If you think about a photo album, think about all the pages, so maybe each page has 6 pictures, and then maybe when you get to the last page of the photo album, whoever was filling it out didn't have enough pictures to fill that last page. So it may not be a full page of pictures, but we can put some pictures on that last page. We don't need to entirely fill it in order for us to use it. So if we have one more page in our photo album, we can absolutely put 5 more pictures on it. Even if we don't fill that whole page, we can still use it. We can still put photos on that page and it'll still work in our photo album. So here, if we look at this last page, we're putting 5 pictures out of 6 total spots that they would give us. So this last strategy that we're looking at is that we want to round the remainder. So this is our third way that we can express or interpret remainders. We want to round the remainder. So now if we go back down here and look at our 1, 2, 3, 4 full pages of pictures, and then this last page we used 5 of the 6 slots that we had to put a picture in on this last page, and they want to know how many pages must he use to hold all 29 photos. So in this case, in this context of our situation or our story problem, we are going to take this fraction and we are going to round it up because Esteban will use 5 pages. he will use 5 pages in order to hold all 29 photos. So let's just recap. If you have trouble, I personally think it's most beneficial to watch the math lesson once through and then watch it a second time through while you're doing your home links, because I think it might help to do it alongside of some of these problems, or it might make a little more sense. That's just my suggestion, but I just want to put on this final page, I want to rewrite all 3 of our different ways that we can express and interpret remainders. So we have our first way, which was to divide the remainder into fractions. Remember, we said that this was most common with story problems that talked about food. Our second is to ignore the remainder, and this is in situations where we physically cannot divide whatever object it is that they're having us look at in the context of the situation or in the story problem. So in this instance, we would ignore the remainder. And in the last strategy that we saw, we would round the remainder. So in all 3 of these instances, like I said before, and I tried to reiterate throughout, each of these depends on the context of the situation or the story problem. So it's very important that you think about the story problem in a real life situation. That's why I drew pictures, because I thought it made it a lot easier to visualize and understand when we draw a picture that goes along with it. So make sure that when we're trying to decide which way or which strategy or method we're using to express and interpret our remainders, make sure we're looking at the context of the situation that the story problem gives us. So this is 6-8. I will also try to find a secondary source of another teacher or someone teaching a similar lesson, and I will post it alongside with this one so you could watch mine. And if you're still having trouble or there's still a little bit of confusion or gray area, you can watch the second video, and hopefully the 2 will connect together and help you to understand a little more clear. So that's it for 6-8.